Previously, you have learned about lines. Now you'll be learning about plane, in which you learn about writing the equation of plane and finding the line of intersection, as well as finding the angle theta between two planes. So let's start with part A, finding the equation of a plane and line of intersection. So plane means that you have a flat surface area, and say that on this plane you have a fixed point. Therefore, that will give you the vector A. So this is your fixed point, and hence the vector A is A1, A2, A3. And each plane will have a normal vector. Note that normal vector means that a vector that is normal to your plane. And normal means 90 degree or perpendicular to the plane. So if this is your plane, therefore the normal vector will be going upward or going downward. So to make it much easier for you to see where is your normal, I like for my normal vector to be going upward, and it is 90 degree to the plane. So the normal vector will be N1, N2, N3. So for plane, you just need two things: vector A that comes from any point on your plane, as well as the normal vector that is 90 degree to your plane. And to write the equation of a plane, you need to use VC, where V is the vector equation and C is the Cartesian equation. So you need to substitute the vector A and N into the equation, and the final answer for vector equation should be written in I, J, and K. So the formula for any plane is always R dot N equal to A dot N, where the vector N is the normal vector, and vector A comes from any fixed point on the plane. And note that for the right hand side, you have A dot N, which will give you a constant, since the vector A has values and vector N has values. Therefore, the dot product of A and N will give you a constant. Next, for the Cartesian equation, you're just gonna write down let R to become the vector X, Y, and Z. Therefore, when you substitute this vector R, which is X, Y, Z, into the vector equation, you will get N1X plus N2Y plus N3Z equal to C. So C here is the constant, and hence you can see that from this equation, if you have X, Y, and Z on one side and a constant on one side, that is the equation of a plane. And the coefficient of your X, Y, and Z will be your normal vector. So that's how you can determine the normal vector from the equation of a plane. Say for example, we have a plane that is parallel to the XZ plane. This is X-axis and this is Z-axis. Therefore, this will be the XZ plane. So, if you have a plane that is parallel to the XZ plane, the normal vector of this plane will be the same as the normal vector of XZ plane. So we need to find the normal vector of XZ plane, which is here. Therefore, the normal vector will be along the y-axis. And we know that along y-axis, the unit vector is j, which can be rewritten in the form of 0, 1, 0. Since j means that it is 0i plus j plus 0k. This is the x-axis, this is the y-axis. Therefore, this will be your xy plane. And say that we have a plane that is parallel to xy plane. Therefore, the normal vector of this plane will be the same as the normal vector of xy plane. So this is your xy plane. Therefore, the normal vector will be along the z-axis. And we know that the unit vector along the z-axis is the unit vector k, which is 0, 0, 1, because vector k means that it is 0i plus 0j plus k. Lastly, say that your plane is parallel to the yz plane. which is here. Therefore, the normal vector of the plane will be the same as the normal vector for the YZ plane, which is actually along the x-axis. And we know that along the x-axis, the unit vector is I. And hence, the vector is 1, 0, 0. So say that you're struggling to remember the normal vector for any plane that is parallel to the xz plane, or maybe xy plane, or maybe yz plane. Just look at the letter that is missing from your plane. If your plane is parallel to xy plane, therefore the letter that is missing from here is z. And hence, your normal vector will be the z-axis. The same goes for YZ plane. The letter that is missing is the letter X. Therefore, the normal vector will be the x-axis. And therefore, the normal vector for XZ plane will be the y-axis, since the letter that is missing from XZ is y.